All right, guys, so I'm hoping to finish up this section today and then maybe start 3.9. Your 3.8 homework will be due Monday. Is that all right? Okay, so we talked about the different inverse trig derivatives yesterday. So now we just have to kind of practice them. Yes? Yeah, I'm just following your, yeah, exactly. I'm following your lead. Yep. We are number 9, back page. All right, so we have derivative of 4x was just 4. Now you have the arc sine of blob, right? So what we're going to do is replace your arc sine derivative formula as like that one x term. You're going to replace that with the blob. So usually arc sine is 1 over square root of 1 minus x squared. So what we're going to do is plug in 2x squared in for x. So you have plus 1 over square root of 1 minus 2x squared, times now the chain rule, right? So what are you taking the arc sine of? The derivative of this now is what? 4x. Right. So your final answer would be 4 plus 4x over 1 minus 4x to the 4th. Sometimes you do. Like if you get like a fraction, like underneath the radical, you need to do a little bit of work with it. But you can leave it like that. Does that reflect my personality? All right, so you have x times arctan radical x, so you have to use product rule, right? All right, so derivative of the first would be what? 1. So I just have arctan of radical x plus now x times the derivative of arctan, which is what? Good. 1 over 1 plus. Now, instead of x, I'm going to replace the x with, right, squared, times now the derivative of square root of x, which is the same thing as. Right. Okay, so is that it? That's it. All right, so you have the arctan of radical x plus now, what does that become? You have x over, if you square the bottom here, what do you get? 1 plus x, right? Well, you're not, right, I'm sorry, you're not squaring the whole thing, you're just squaring square root of x. and then times 1 over 2 radical x. Just rewrite it like how it was the original. Okay, so you have arctan radical x plus now x over 2 radical x times 1 plus x. All right, can you simplify the second term at all anymore? You could, you don't really have to. I'm more looking at like these two guys. Can I simplify that at all? So this is really x to the first, and then this is x to the 1/2. So if you put them over each other, you're left with what? X to the 1/2, right? So you can leave this now as radical x over 2 times 1 plus x. And you can distribute if you would like, but you don't have to. Yeah, I think so. Because most of the time, like, they'll like ask you for this, and then you have to like plug something in. So like, if you plug something in here or here, you really should get the same thing. Okay, and then letter C. How can you rewrite that? If I'm taking arc secant of sine of 3x divided by 5, it's really the same thing as multiplying it by, right. So you have 1/5 arc secant, and then you have sine of 3x, right? All right, so the derivative of arc secant. No, this is still like your original function. Right? So you have the 1/5 and then the derivative of arc secant. So you have 1 on the top. What you're taking the arc secant of goes inside the absolute value. I'm just leaving this on the outside for right now. I'm just worried about like figuring out this first, and then we'll simplify it later. And then the second part of arc secant's derivative would be like the blob squared minus 1. So you have sine sine of 3x squared minus 1. Now you need the derivative of sine, because you got to use chain rule. That would be what? Cosine of 3x, and then the derivative of 3x is just the 3. Okay, so I see that I have, what do I have? I have 3 and a 1/5, right? So I can kind of put them together. So 3 goes on top, cosine of 3x over absolute value of sine of 3x times sine squared 3x minus 1. I forgot the 5. Alright, so we can leave it like that. This here is like one of your Pythagorean identities. So you have like sine squared plus cosine squared equals 1, right? So if I move cosine over and move the 1 over, right, that would give me the same thing as what that is. So I can replace here with negative cosine squared, but that's, you can't take the square root of that. So technically the whole thing is undefined. But it's too good to just practice. It's good to just practice the technique. Okay, so it says find the derivative of that and then simplify to a single term. Okay, so derivative of arc sine turns into 1 over square root of 1 minus x squared plus now what you have x times 1 minus x squared square root of that. So you have to use product rule. So you have 1 times 1 minus x squared plus now x times the derivative of square root of 1 minus x squared becomes what? So the negative 1/2, good. Times the derivative of the inside, which is negative 2x, right? All right, so what we want to do is we want to take all of this and try and get it down to one single term. All right, so how can I rewrite this first term here? Right. Okay, good. All right, and then I have plus. How can I rewrite this term here? Okay, good. And then the last one, I have, what do I have? I have x times 1/2 times negative 2x. So what would that give you? Right? So negative x squared times 1 minus x squared to the negative 1/2, right? Okay. What can I take out now? To the what? Not the 1/2, but, right. You want to do least powers. So negative 1/2 is less than 1/2, so this one's smaller. Okay, so if I take that out, right, this term here times what gives me that? 1. Plus now, this times what gives me? Not negative 1. The exponent here is negative 1/2. The exponent here is 1/2. So this one is greater than this one by an exponent of 1. So all you have to do is just rewrite what you have on the inside, and technically you have like a 1 on the outside, right? So if you were to multiply this times that, right, you have the 1 minus the 1/2, which gives you the 1/2. And then minus x squared. So I have 1 minus x squared to the negative 1/2. And then what do I get on the brackets? Okay, good. 2 minus 2x squared. So you have, even, like, see how this is like in parentheses, but it's raised to 1? So it's really the same thing as that. It's not even there. So you can like almost erase the parentheses. So then you have 1, 2, and then you have negative x squared, which gives you that. What else can you take out from here? Take out a 2. So you have 2 times 1 minus x squared to the negative 1/2 times 1 minus x squared, right? Now, if I multiply this here times this, right, because this technically is in, oops, sorry, this technically has a 1. What would you get if you were to multiply this times this? 1/2, right? Good. So you have 2 times 1 minus x squared to the 1/2, which is 2 minus x squared. So now you have a single term. Well, so terms are separated by either addition or subtraction. So, like here we had 3 terms, 1, 2, 3, and then we just wanted to work it down until we got 1 term. Yeah, but it's not simple. Huh? What did you say? I do. Like this? Partial. This is what I'm after. Yep. Here to here? So, factored out a 2, right? And you're left with that, right? So, technically this is like in parentheses and then there's a 1 as your exponent. So if you were to take, imagine taking like x to the negative 1/2 and then multiplying it with x to the first. You would add the exponents and you would get 1/2, right? So you can really just treat this as like a variable, right? And this, when you multiply them together, what is on the inside stays the same. And then all you're doing is just changing the exponent. So you have like negative 1/2 plus 1 gives you that 1/2 when you multiply them together. Right. Which one? 9a?